Today, what the directions say is to find the first three positive values of x. So again, going back to the first day when we were graphing. If I was graphing a sine graph, it would look like this, look like that. If I asked you to find the first three positive values of x, well, this is one of them, right? If I said sine of x equals 0, is 0 a positive number? No, it's not. It's not positive or negative, so that wouldn't count. So I would go to the next one. Here's the first positive. Here's the second positive. And then I would keep going. Here's the third positive. So I could do that with a graph. But again, we're not graphing today, so we don't need to do that. What we're going to do is use the unit circle. So here we have sine of x equals negative root 2 over 2. Same type of problem we did yesterday. Yesterday it would have said find the general solutions. Today it says find the first three positive values of x. So again, I like to draw the circle and think about it. If you have your unit circle out, that's fine also. So I want to think about where is sine of x equal to negative root 2 over 2. Well, that's going to be right here at 5 pi over 4. Oh, but we're in degrees, so that's 225 degrees. So at 225 degrees, and then it happens again right here at 315 degrees. Both of those places, if you were to say what is sine of 225, you would get negative root 2 over 2. If I were to ask you what's sine of 315, you would get negative root 2 over 2. Both those places is where that happens. The directions say find the first three positive values of x. So think about the unit circle. I'm going to start at 0 degrees. Positive goes in this direction. So the first time it happens is at 225 degrees. That's the first. Then I want to know the second positive. So if I keep going around the circle, here's the second. The second time it happens is right there at 315 degrees. And then the third time it happens, so again, here was 1, here was 2. It's going to happen again if we keep making a rotation at 225 plus 1 rotation, which in this case is 360 degrees. So the next place it happens is 225 plus 1 rotation on the unit circle, which is 360 degrees. So your next answer would be 585 degrees. And there are your first three positive values. When there's no period change, if that seems really easy, it is that easy. The thing that makes it a little more difficult is when there's a period change. If there's no period change, then all you have to do is think about the unit circle. You don't have to think about what is the period or anything like that. It's helpful, okay? It works the same, but if there's a period change, meaning b is something other than 1, that's when you have to think a little bit more, and you can't just use the unit circle to add to get to the next number. Okay? If I had said what are the first four positive values of x, I would have gone here. Here's my fourth one. It would have been 315 plus 360. If I would have asked for 5, 225 plus 360 times 2, that n value. We made 2 rotations. The 6th, 315 plus 360 times 2. The 7th, 225 plus 360 times 3. The n is how many rotations you're making when you're thinking about the general solutions. All right, the next one, cosecant, and there's a period change. The first thing you have to do is get that cosecant of 3x by itself. So first we want to subtract the 2. So we get root 3 cosecant of 3x equals negative 2. Then divide by root 3. So when that happens, we get cosecant of 3x equals negative 2 over root 3. Now, you had some of these on your homework last night, and some of you were thinking, okay, well, cosecant is 1 over sine, which is true, but that doesn't help us. Thinking of cosecant as 1 over sine doesn't do us any good. It is correct, but what I want to do is I want to change that to a sine. I don't want to change it to 1 over sine, because 1 over sine doesn't help me do anything. Even though it's correct, it doesn't get me anywhere. So the reciprocal of cosecant is sine. So I can say sine of 3x. If I change the left side to the reciprocal, I also have to change the right side to the reciprocal. So cosecant and sine are reciprocals. Therefore, this side has to be the reciprocal. So I have to make that negative root 3 over 2. You don't have to do that. I think a lot of times with sine and cosine, because of secant and cosecant, it's easier to just think about the unit circle and know where all those numbers are versus thinking about the reciprocal of those numbers. It's easy. Changing tangent to cotangent doesn't really save you any time because you have to do y over x versus x over y. So I don't think there's any need to do that. But for secant and cosecant, I would suggest doing that. Okay? Both of these equations are completely the same. Here you're looking for where is the y value, the reciprocal. Here you're looking for where is the y value equal to this. Both of them are the same. Now, we have this period change. So that's when we have an extra step in there. We can't just look at the unit circle and find our answers like the last one. We do have to look at our unit circles and figure out where the y is equal to this number right here. So you can think of it as the inverse sine of negative root 3 over 2 equals 3x. A lot of times when there's a period change, I think it's a good idea to write that step. While it's not necessary, it is helpful because it helps you remember that you can't just say x equals. You're going to have to say equals 3x and then solve. So inverse sine of negative root 3 over 2. So all that's saying is where's y, negative root 3 over 2. And that's going to be right here at 240 degrees. And right here at 300 degrees. Those are the two places that happens. So I set both of those equal to 3x. So 240 equals 3x, and 300 equals 3x. And then I just solve for x, and I have my first two answers, 80 and 100. Now, if writing your general solutions each time helps you, then you can do that. That's not part of your answer. It's going to be important that you know that on tests and quizzes. You know what your answer is. You don't just do everything and box everything because that means you don't know what you're doing. You have to do what the directions ask. So, my first answer is 80 degrees. That's the first positive answer. The second positive answer is 100 degrees. The third answer is going to be not necessarily a rotation in this case because one rotation is 360 and our period is not 360. Our period right here is 360 degrees divided by 3. So that means instead of answers happening every 360 degrees, they happen every 120 degrees. So we've got to figure out what is the next value that happens 120 degrees from a value. So 80 is where we start. Now we have to think about, could we subtract 120? We could, but if we subtract 120, we get a negative. So negative values are out. So if I take 80 and I add the period, I get 200, which obviously is going to be smaller than if I add the period to 100. So those are my first three positive answers. Because remember, there's an infinite number of answers. We're just finding the first three positives. We already did that. So 300 equals 3x. So I just didn't show that step right there, divided by 3. So x equals 100. So here divided by 3, divided by 3, x equals 80. So those are my two answers that I get off this unit circle because I can't just say there's only two answers right here. I can for this right here. Inverse sine of negative root 3 over 2 produces two numbers. I mean, really it produces an infinite number of numbers, but if we keep repeating them, then we're just repeating the same thing over and over again. So we set this is the equation we're solving right here. So once I solve that equation, I have what x equals. Those are my numbers. So if I was writing general solutions, I would say x equals 80 degrees plus the period times n. X equals 100 degrees plus the period times n. So those are my general solution. if I were to say find the general solutions for this equation, that would be it. So it starts at 80, and every 100 degrees, every 120, whether we go forward or backward, there's an answer. And if I start at 100, every 120 degrees forward and backwards, I have an answer. So now the question says, what are the first three positive values? So remember, n is an integer. So if I plugged a 0 in for n, I'd get 80 plus 0, which gives me 80. If I plug a 0 in for n right here, I get 100 plus 0, which is 100. So since I want positive, now I'm going to plug a 1 in. So if I plug in a 1 right here, 80 plus 120 times 1 is 200. If I wanted the first four positive, 100 plus 120 times 1, I get 220. And it would be that way forward and back. Because remember, this is a graph that looks like this, and we're finding answers that it equals. So it's going to equal 80, then it's going to equal 100. Then it's going to be 80 plus 120, 100 plus 120. 80 plus 120 times 2, 100 times plus 120 times 2. And it's going to do that forever. Does that help? Other questions? So if writing these general solutions to the problem helps you, that's fine. Just be sure not to include them in your answer if the question is find the first three positives. All right, then we have use radians. So the last two problems we're just going to do in radians. So the steps are the same. You're just in radians versus degrees. First goal is always to get the sine theta, or whatever the word, by itself. So you divide by 5, and you get sine of theta equals 1. So again, we think about our unit circle. There's no period change, so we don't have to worry about that. So think about our unit circle. How many times does y equal 1 on our unit circle? Once. Okay, that's different than tangent and cotangent. Sine and cosine, 1, -1, and 0 happens on a quadrantal. Tangent and cotangent, 1 and -1, does not happen on a quadrantal because it deals with the x and the y. So the only place that y is equal to 1 on our unit circle is up there at the top at pi over 2. So if we want the first three positives, the first positive is pi over 2. We start at 0, we go to pi over 2. The second time it happens is after one rotation, because again we have no period change. So one rotation is going to be pi over 2 plus 2 pi. So we get 5 pi over 2. The third positive is going to be another rotation. So you add another 2 pi. You get 9 pi over 2. And there are your first three positive values. And again, you need to be careful when it's on a quadrantal, because if that had said, I guess, let's see, sine of theta equals 0, the first time that happens is at 0. If it asks for the first three positives, you've got to remember that 0 is not a positive number. That's the one thing that's a little bit tricky. You've got to be careful with 0 when it asks for the first three positive values of x. All right, and then the last one, tangent of x equals -1. No period change, so that's kind of nice. So where does tangent of x equal -1? So basically that's where is x and y the same with opposite signs? Well, that's going to happen right here at 3 pi over 4 and down here at 7 pi over 4. So our first value is 3 pi over 4. That's the first time. Starting at 0, here's our first positive. Our second positive, 7 pi over 4. And then our third positive, if we kept going, we end up right back here at 3 pi over 4, but after a full rotation. So we could say 3 pi over 4 plus pi, 7 pi over 4 plus pi, or we could do 3 pi over 4 plus 2 pi. That produces the same result. 7 pi over 4 plus pi, or 3 pi over 4 plus 2 pi. Because remember, tangents are across from each other right there. So that's kind of a special case with tangent and cotangent when it's in the middle like that. So then our second one, or we could even just count. Remember, this is 1 pi over 4, 2 pi over 4, 3, 4, 5, 6, 7, 8, 9, 10, 11. However you think about that, you get to 11 pi over 4 as your first three positives. Okay, so when there's no period change, the best thing to do, I think, is to use your unit circle and just look at it. When there's a period change, meaning the b value is not 1, that's when the general solutions will be a little bit more helpful to you to figure out what the next answer is. Or just know that answers happen every period. So you take the first one, the second one. To get the third, you take the first plus the period. To get the fourth, you take the second plus the period, and so forth. All right, any questions?